is also joined now here, Dr.
Yeah.
Amol. We did not participate, and we are unfortunate to miss that session.
Correct. No, but nothing is missed. I'll circulate you that the PPTs and other things. So don't worry about that, sir. Yeah. Hima ma'am, are you there? Are you audible? Am I audible to you? Or anyone who is audible and would like to give some reflection about whatever we have learned yesterday, to make the session more interactive.
Yeah, good evening,
The session more interactive. Good evening, ma'am. Yes, if you can you open your camera? Would you like to open and let Pallavi ma'am? Yes.
Yes.
Yeah. Welcome.
Good evening, everyone. Yes. Just I one brief about this yesterday's topic. We have, I guess, developed one model. Like we have taken dependent variable, one independent variable, and so many dependent variables. That model was like we have checked first the relationship between the model and then coefficient of determination R square also sir has explained very well, like if there is a negative regression coefficient is like above 0.75, then it's like there's a model is a good fit model, we can say. And if that is below 0.5, then we should reject that regression model. So, and adjusted R square, someone has asked the question, so he explained it very well. Adjusted R square also. Okay, sir.
Thank you so much, madam. Yes, really, you have given that all the right inputs, like whatever we learned yesterday.
Yes.
So thanks a lot, and we'll make the session today more interactive because now we know each other more. Now, can anybody else can come forward and give some reflection about the yesterday's learning? I see few names like Dr. Ankush. Dr. Ankush, am I audible to you?
Yes, hello.
Ankush, if you just give your brief introduction, so that we want to make this session more interactive, so that there is much silence. So just tell about your college, about yourself, and then give some reflection about that.
Yes, sir. Actually, I'm from Sigmoid Institute of Management, Pune itself.
Oh, great. Yeah, so we'll see you on the 12th.
Want to learn new things in the AI, right? So I'm little bit that much not having that much knowledge about the AI. So want to learn something from this session.
Great, Dr. Ankush. Yeah.
Thank you, sir.
Thanks a lot, Dr. Ankush. Yeah. So, anyone else? Ankit, I see one.
Ankit, Dr. Ankit is also our colleague. Morning we came and visited at you.
Yes. Yeah. Kamal sir, yes. So, are you there, Alaskar sir? Dr. Kamal Alaskar. Or anyone else who is listening us and would like to give some reflection?
Yes, sir.
Yeah, Rupali ma'am. Yes, yeah. Give brief. Yeah. Am I audible to you, Rupali ma'am?
Yes, sir. Myself, Rupali Shetty. I am from Kuslavadi Institute of Technology, Pune, sir.
Okay.
I am pursuing my PhD, and I need machine learning algorithms and all further in my research. So I'm more interested in this FDP.
Great. Yeah. So,
Yes.
So thanks for sharing, and Rupali, want to make it more interactive, like you can ask questions and also give your reflections whenever required.
Yes, sure.
Okay, thanks a lot.
Thank
Thanks
you.
a lot. Yeah. So now once again, I welcome Dr. Mithun. And why I say doctor? Because he's the doctor's doctor. Okay, because he's the subject which is teaching, and that is he's teaching to all doctors. Okay, so Mithun, am I correct? So I will just give a brief. Mithun sir, you are ready?
Yes, I'm ready, sir.
Yeah. So those who have just joined just now, I can give a brief introduction of Mithun sir. So Mithun sir, he's the Masters in Statistics from Bangalore University. He's having heterogeneous crowd involving marketing, pharma, HR, supply chain, and logistics. And he has more than 15 years of experience with the Qatar National Research Foundation, with the Net app, and also with the Dubai Customs. And he has worked with the many MNCs, and he has dealt with the fraud analytics in finance, credit risk analysis, value at risk, and also HR analytics. Also, he has attended. So in HR analytics, he has done attrition analysis, then compensation and benefit analysis, and other analysis also he did it. So I see that, okay, he's having a very vast experience in the field, and he's the master in industry who is dealing every day the new challenges in the industry. So on behalf of all of you, and also on behalf of the AICT Atal Academy, I welcome Mithun sir once again. And now it is over to you, Mithun sir. Please take it over and then tell us the next part of the linear regression, okay, and also the machine learning. Thanks a lot, Mithun sir. Now it is over to you.
Can I share my screen?
Sir, can you be louder? Your voice is just a bit low. Yeah, now it is okay. Yes, Mithun sir.
I was just asking, can I share the screen because it is?
Please. Yes, please. Yeah.
It is not. It is not supported.
It is not supporting.
Yes, it is not supporting. Okay. Just 1 second, sir. I'll just log in through another browser.
Okay. Please. Stellan, am I audible to you? Yeah, Stellan. Yeah. Am I audible to you? Yes.
Yeah.
Okay. So yesterday you were there, Stellan. Okay, can you give some reflections about that? In the meantime, okay, he's changing his browser. The speaker is changing his browser. Or tell about yourself, like, okay, your college and the other things. Am I audible to you, Stellan? Yeah.
Yes, sir. Can you hear me now, sir?
Yes, sir.
Yeah. You are audible, Mithun. Stellan, yes.
Yeah.
Over to you.
Okay. Okay. Can I get started, sir? With today's
I think he started. I think so, sir.
Okay, Stellan. Okay, in between we'll take you. Okay, you can just
Yeah. Okay, sure.
Okay, sir. Yeah, bye. Mithun, please. Now it is over to you.
Yes, thank you so much, sir. So firstly, welcome, a warm welcome to all the participants, and thank you so much, Shukla Sab, for a warm introduction. So day 2 of this workshop, right? Day 1, we looked at linear regression. So at a very high level, if I have to summarize linear regression, 3 points. The operative word is linear, which means there should be a straight line kind of a relationship. Second point is that the dependent variable must and should be scale variable, or it should be numeric, because linear regression does not support categorical variables and such things. And the third important point is that in the case of linear regression, you get how do you assess whether the model fits the data well or not? You can assess whether the model fits the data well or not through R square, which one of the participants was earlier talking about, which is called as quotient of determination. Now, with this background, linear regression, if you recall, is an example of supervised learning technique. I repeat, it's an example of supervised learning technique. Now, day 2, I'll be talking about another important technique, and that technique is what is called as logistic regression model, right? Now, logistic regression model falls under the wider class of models which are used to address classification problems. So what do I mean by classification problems? I'll just tell you in a bit. The third important point which I would address is model diagnostics, which are the important model diagnostics that we get under logistic regression. Fourthly, we look at a few use cases and also certain disadvantages of using any technique, that is logistic regression model, right? So these are the 5 points that I'll be covering in today's presentation. Firstly, I'll just talk about at a very high level what is logistic regression. I'll use around half an hour to give you a theoretical background about it. Post that in Jupyter Notebook, as we did yesterday, I'll just show you with the help of a case study how we can implement a logistic regression model. Okay. Firstly, have you heard of logistic regression model? Anybody has heard of logistic regression model? Anybody? It's a question open to the participants. Has anybody heard of logistic regression model, used it?
Yes, sir. Logistic regression, we had it where it can make out certain decisions. Like if you have materialistic mix up of many things, then the model will definitely able to distinguish between among the data points.
Okay. Okay, so fundamentally, let me just take you back to the last class, wherein I spoke about linear regression, and I emphasize the fact that linear regression is used when the dependent variable is scale variable. Now, the obvious question there is, what happens when the dependent variable is not scale? What happens when the dependent variable is categorical in nature? For example, you want to find out what is the profile of those customers who are low profitable, medium profitable, or moderate profitable, and high profitable. Right? You are doing a profile analysis. Or let us say you're trying to do an analysis which, let's say you are working in a bank, you're a bank manager. A lot of students come there asking for an education loan. Now, the fundamental problem there is to identify whether or not you should give a loan to a student, because many times students take the loan and they do not repay, which means it's a loss to the bank. Now, why should I suffer a loss? So even before I grant a loan to my audience, to my customer database, to my customer, to any of the customers, I would like to identify whether he is eligible to get a loan or not. In other words, I want to find out whether a customer is a risky customer or not a risky customer. So the dependent variable that we are trying to predict is not scale, as in the case of linear regression. It is a categorical variable. Let's say you want to identify whether a person will default upon the payment on loan or not. Yes or no. These are the only two cases that are possible. Right? Is a customer a fraud customer or not a fraud customer? Is a customer a highly profitable customer or a low profitable customer? Or in a telecommunication company, let's say you are subscribing to Vodafone, right? And you're, let's say, or Idea, you're not very comfortable with the service of Idea, right? You're not very comfortable with the service of Idea. So you're thinking of moving from Idea, away from Idea to, let's say, Airtel. Now you are likely to do what is called a churn. Churn means basically leave. So in telecommunication, the chief problem there is to find out whether a customer will churn, that is leave or not. So if a customer leaves, then it's a problem, because in any subscription-based company, if a customer leaves, it's like losing blood. The moment customer leaving the organization is like losing customer is like losing blood. You become very, very weak. You don't want to lose customers. So there, the problem may be to identify whether you'll churn or not. Again, a dichotomous variable. So for any of these problems, whether it is identifying if a person will default upon the payment or a loan or not, or whether it is to find out whether a team will win or not, or maybe we want to find out whether a person is a fraud or not, or you may want to find out if I send a direct mailing campaign, will a person respond to my direct mailing campaign or not? Or you can have an example in the healthcare wherein you want to identify based on cell characteristics that whether a person is likely to suffer from cancer or not. All these are problems wherein the dependent variable is a class variable. It's a categorical variable. It is not a scale variable. So in these cases, in any of these cases which we were discussing, that is cancer prediction or default prediction, fraud prediction, who is a high risk customer, low risk customer. In all of these cases, we can't use linear regression model because fundamentally linear regression model is not designed to handle categorical dependent variable. This is where logistic regression model comes into picture because it is designed to handle categorical dependent variables. So far it's clear? Is it clear so far?
Yes, sir.
I think yes, it's clear, Mithun. Yeah.
Okay. Now let's talk about logistic regression model. Within logistic regression model, there are two types. One is what is called as a binary logistic regression model. The second one is what is called as multinomial logistic regression model. I'll be discussing what is called as the binary logistic regression model. Now, this model is most useful when you want to model the event probability for a dichotomous response variable or a variable with only two outcomes, right? If the dependent variable is having only two categories, whether it will rain today or not, whether India will win the match or not, whether you will default or not, whether a customer is a fraud or not, whether you will respond or not, whether the cell characteristics indicate tumor or not, yes or no, binary outcomes. Because the outcome variable is binary in nature, we will use a technique which is called as binary logistic regression model. Very simple, right? Linear regression does not come into picture because linear regression is not designed to handle dichotomous variables, right? Now, what are certain key features or important characteristics of this kind of a model, right? There's a lot of text here. Let me just break this down one by one. Now, the first point is that it is used in the supervised machine learning technique. Yesterday also you saw when we used linear regression, was that supervised or unsupervised?
Supervised.
Why do we say that?
Because we know the label in advance.
Yes. Which was the label yesterday?
The rate.
Housing price, correct?
Housing price, yeah.
Yes. So logistic regression also is an example of supervised machine learning technique itself. Second point is that it is used for predicting the categorical dependent variable. There is no question of having a scale dependent variable. We expect the dependent variable to be categorical, correct? The third point here is it predicts the output of a categorical variable, which is discrete in nature. That is yes or no, 0 or 1, true or false, like a Boolean, right? This is what we are trying to predict. Philosophically, it is very similar to linear regression. There's not much of a difference between linear regression and binary logistic regression because in both of these cases, at the end of the day, we are doing a prediction itself. What is the main difference then? The main difference is that linear regression is used for solving regression problem or prediction problem, right? So if the dependent variable is, if the outcome variable is scale in nature, that is called as a prediction problem or a regression based problem. On the other hand, if the outcome variable is categorical in nature, it is called as classification problem. I repeat, it is called as classification problem because at the end of the day, we are trying to classify an individual based on his demographic details, based on his psychographic details, so on and so forth, into one of the two categories, defaulter, non-defaulter. So what am I doing? I'm classifying a person. Either he's a fraud or not a fraud. What am I doing? It's again a classification-based problem. The last of the points here is that in logistic regression model, the S-shaped logistic function is used as the fitting curve. Now, this is important. In the case of linear regression, yesterday I showed you the mathematical formulation, which is basically y equals b0 plus b1 x. b0 plus b1 x1 plus b0 b2 x2, whatever it is, correct? Now I can't use that function because if you take the sum product, if you take b0, let's say b0 is 100, 100 plus b1 is 50, and your x1 is 2, right? 50 into 2 is again 100, 100 plus 100 is 200. You will get 200, right? So like this, if you take the sum product of the right-hand side of the linear regression, you can get any large value. But remember, our output variable has to be squeezed between 0 and 1 only. So when we have the output variable, if I'm getting a value of minus 50 or 800, I can't make sense of this. Therefore, in the case of logistic regression, we do not use a linear curve. Mx plus c, that is not what we use. What we use is a S-shaped curve, popularly called as logistic or a sigmoid function. We are using a logistic or a sigmoid function, and this chap returns any value between 0 and 1. It either returns 0 or 1. So sigmoid function, I'll just show you how it looks. So far, is this discussion clear?
Yes, sir.
Okay, so
yes, sir. Mithun, I think yes. If you can repeat some part of it in brief, yeah.
So there are 4 points about logistic regression. 5 points. One is its supervised learning technique. You already know what supervised learning technique is. Dependent variable is binary in nature. Yes, no, right? You can't have scale variable. Logistic regression is used to solve what is called as classification problem. Classification problem means basically whether a person suffers from cancer or not, whether a person suffers from heart attack or not, whether a sports team will win or lose, yes, no, fraud, not a fraud, default, non-defaulter. All these are yes, no kind of a situation, and therefore you can use this. Last point is that in the case of logistic regression, the S-shaped logistic function is being used as a fitting curve, right? We can't use a straight line equation here because a straight line equation is a bit of a problem, right? So we use a mathematical curve which is called as S-shaped. Why is this called as S-shaped or a sigmoid function? I'll just tell you, but this is the highlight of, these are some of the highlights of what I'm talking about. So far it's clear, guys?
Yes, sir. Yeah, it's clear. Yeah.
Okay. Anyway, I know that last point may not be last point may not be very clear to you. I'll just explain what is the meaning of sigmoid function. Just keep this point in mind. Okay. Now let's just keep this dialogue flowing. Correct.
Right.
Diagrammatically, if I have to just show how it looks, you can just see here. I just picked up this picture from the net here. It's not my picture, so let's give credit where it is due. So these are my input variables, x1, x2, x3. We have to establish its coefficients. Just as we found out the coefficients of a linear model, we have to find out the coefficients of theta 1, theta 2, and theta 3. Multiply it, right? Take the sum product, right? Theta 1 into x1 plus theta 2 into x2 plus theta 3 into x3. Push it into a function, right? Which will return only two outcomes. Either a person is happy or sad, right? Here I'm showing the example of happy or sad. It could be fraud or not fraud, churner versus non-churner. Any of these things are possible, correct? So this is this centerpiece, which you see is more like a black box, which I'm going to explain in a few moments from now. Okay, so this is basically the geometric explanation or the diagrammatic explanation of what is logistic regression model all about. Now comes the important point, right? Can you see here? I'll just take you 2 steps back. Here I said that in logistic regression, the S-shaped logistic function is being used as a fitting curve. I'm using a sigmoid function or a logistic function to fit the curve, which always gives an output between 0 and 1. Let's look at this. Look at y here, which is the vertical axis, and look at x here. Do you notice anything interesting about this graph here?
The graph, some points it is a saturation type, and sometimes there is a increasing in the middle part, and the exact midpoint of the rising curve is the threshold value.
Okay. Okay, just look at the beauty behind this curve, correct? Here, if you look at this curve here, it is S-shaped. Do you agree? So this is a sigmoid function that we will be using. And the most interesting part here is, right, the x value can be anything. No matter what you pass into this, the outcome is limited between 0 and 1. It is what is called as a squishing function, which does not allow the output to be greater than 1 or smaller than 0. It will always squeeze the output between 0 and 1. If the value is greater than 0.5 or it is more than 50%, it will be called as 1. Let's say when I study a person's demographic details and such things, and I pass it through the S curve, the output may be 0.8. 0.8 is closer to 1 and it is farther away from 0. Since there is an 80% chance that a person is going to be a defaulter, which is quite close to 1, I will be calling him as a defaulter. Let's say there is another person who has barely 30% chance of defaulting. 30% is close to 0, and therefore I will be calling him as a non-defaulter. So this is the beauty of this function. No matter what you pass inside this, the output will always be between 0 and 1. Greater than 0.5, it will be called as 1. 1 may be the notation for defaulter. Less than 0.5, he will be called as 0 or basically a non-defaulter. Is this clear?
I think some more clarification if you give, that will be better because.
Okay. Can I just open an Excel sheet and just tell you how it works?
Yes, sir, please.
Right, I'm just deviating from the subject here.
Correct.
It is relevant so that you understand this. Okay. See, what is the formula that you saw yesterday? Can you see my Excel sheet?
Yes, we are able to see.
Let me just zoom this in. So if you recall, this is the equation, mathematical equation for a linear regression model. Do you agree?
Yes.
Y equals B naught plus B1 x1 plus B2 x2. Do you all remember? This is your linear regression model. Right? This is a typical linear regression model. Now, what is the problem with this? Let us say your B naught. I'm just giving an example here, right? RHS, just focus on the right-hand side of linear regression model. Your B naught may be 2. I don't know, right? Your B naught may be 2 plus B1. It is nothing but the coefficient, correct? Yesterday, when you looked at your intercept term, I think you got around 2. Just I don't know what is the exact number. Don't worry about it. Plus 3 times, let us say crime rate in a particular locality is around 2.5. Plus, let us say B2. B2 is what here? Some number. It is some number. 4 times, let us say x2. What is the second independent variable that we had taken yesterday? One was crime rate. Second one was, let us say, NO2, pollution level. Pollution level, I don't know, is around 30%. I'm just imagining for some locality, it is 30%. Like this, you may have 5 times the next variable, which is basically the third variable could be
population of black.
Sorry?
Population of black people.
A population of black people, that may be around, let's say 5%. So let's say 0.05. Like this, you may, I'm just telling you that right hand side is nothing but sum product. And when you do a sum product, you are getting 13.2 as the expected housing price. So far, is it clear? $13,000 would be the expected housing price.
Correct.
Right?
Yes.
Now, my fundamental question here is 13.2 is fine. In the context of linear regression, yes, it makes sense. But here, if we are trying to predict whether a person is going to suffer from cancer or not, what does 13.2 tell me? It tells me nothing. I don't know. How do I interpret 13.2? My Y here, in the case of logistic regression, it just binary. It is either 0 or 1. I am getting a value of 13.2. It has exceeded the threshold of 1. Can I make any sense of this? You can't make any sense of this at all, right? 13.2 cannot be made any, you can't make any sense. There is no, I can't interpret this number at all in the case of a logistic regression model. And therefore, what we do is we are just changing the mathematical equation. We are doing mathematical gymnastics. We are doing just a bit of mathematical jugglery here. Now, that mathematical formulation is called as sigmoid formulation. You're just changing the formula at the end of the day so that the output is limited between 0 and 1. It should not go above 1. It should not also fall below 0. That mathematical jugglery, that mathematical workout that we are doing is what is the essence of logistic regression model. Now, how can I convert a number of 13.2 between 0 and 1? Correct? First thing is basically, you can see here, this is the right-hand side of what? Right-hand side of equation 1. Correct? Right-hand side of equation 1. Now, with your permission, I'm just going to do a bit of mathematics, right? Nothing else. Can I attach a negative sign to this number? Let's look at what happens. Equals negative of this. I attach negative of this, I'm getting this as minus 13.2, right? I'm just attaching a negative sign to the right-hand side of my linear regression, nothing else, right? Attach a negative sign. If you attach a negative sign, don't you think this is nothing but minus B0 plus B1 x1? Instead of writing this complex equation, which is there here, let me just reduce it to the first two terms itself. The philosophy will still be the same, correct? Here, what am I saying? I'm just saying, boss, attach a negative sign to this entire quantity. Right? I'm doing nothing but attaching a negative sign. So to attach a negative sign, let me just use this text. So far, are you able to understand what I'm saying? B0 plus B1 X1. When I just multiply this, I may get 13.2. I'm just putting a negative sign here. So far, is it clear? Able to understand? Not able to understand?
What was the value of B0?
Sorry?
In earlier equation?
It could be anything. It's just a number. 13.2, you can get 40, 50, 60, 80, anything you can get. It's just the interceptor.
No, in the first equation, linear regression, we got the value 13.2 by putting some values into the right-hand side of the equation.
Yes, you're right.
So that time, what was the value of B0?
2. Let's say 2 here.
So is it related to this B1 or B0 or it is different?
It is the same thing. It is the same B0, same B1, same X1. Right-hand side will remain the same. There is no change in the right-hand side. Except that in the second step, I'm just attaching a negative sign. Okay, this is one thing, correct? Now, after attaching this negative sign, what I'm going to do is I am just going to take exponential function. We all have heard exponential of minus this, whatever is there above. What do I have above? Minus sign of, right? It is B0 plus B1 X1, so on and so forth. I'll just limit myself to B0 plus B1, which is as good as saying, right, equals exponential of this number minus 13.2. When I take the exponential, do you see here the number becomes very, very small? Are you able to understand this? Look at this. This number is 1.85 into 10 power minus 6. Earlier, my problem was 13.2, which was not interpretable. I am attaching a negative sign, passing it through the exponential function. I'm getting a very, very tiny number. Are you able to understand where we are going with this?
Yes, but I have some question.
Yeah, this is not complete. I have to still finish the formula. Okay, so I'm just taking exponential. After this, what I'm doing is basically I'm adding 1 plus exponential of, I'm just adding 1 to this above number. Nothing else I'm doing. I'm just adding 1 to this above number. So it is exponential of 1 plus exponential of minus B0 plus B1 X1, right? So when I do this in the left-hand side, I should do the same thing to the right-hand side as well. So you are getting this number. So you are getting a number which is greater than 1. Do you agree with this? So now?
Yes.
Now you are getting 1 divided by, this is just nothing but I'm taking the right-hand side of my linear regression output, which is 13.2, which is hard to interpret, attach a negative sign, pass it through the exponential function, add 1. And as a final step, you know, what am I doing? I'm just dividing this entire quantity. I'm just taking the reciprocal of this 1 divided by this number. When I do 1 divided by this number, you can see here I'm getting a number between 0 and 1. So in the right hand side, if I have to write this, 1 divided by 1 plus exponential of RHS of my linear equation. RHS of linear equation, correct? So this entire formula is nothing but your sigmoid function. Geometrically speaking, it is just a S-shaped curve. So what I'm doing is basically take 13.2 or 13 million or 3000, pass it through this formula. The output will always lie between 0 and 1. Earlier we had 13.1. Now I have a number between 0 and 1. Since it is closer to 1, I can say that there is a higher chance. Let's say we are talking about cancer prediction, right? There's a higher chance that the person with these characteristics, X1, X2, X3, is likely to suffer from cancer. So this mathematics is what is shown here, is nothing but a S-shaped curve that is shown in the graph. Correct? So the moment you take the right-hand side and pass it, you'll always get a value between 0 and 1. If it is greater than 50%, we'll say, yes, the person is likely to be a fraud. If it is less than 50%, we are likely to say that the person is not going to be a fraud. So this is the essence of logistic regression model. So this is called as S curve. S curve. What is the mathematical formulation of S curve? Let me just show you the mathematical form. Look at this. This is what I was trying to do in Excel. Do you see here? 1 divided by 1 plus e power minus x. So this 1 divided by 1 plus e power minus x is the equation for a sigmoid curve, which is nothing but, right, which is what I was trying to do in Excel. Look at this. 1 divided by 1 plus e power minus right hand side quantity of your linear equation. Why should we use this formula? You have just now seen that the moment you use the exponential curve or the sigmoid curve, this is 7th step, whatever you're seeing here. Let me just highlight this for you in yellow color. This is the same equation which will give a value between 0 and 1. Why do we need a value between 0 and 1? Because that is the essence of binary logistic regression model. Right? I'll just come back to this. Please tell me if you have been able to follow this.
Sir.
Yes, sir.
Please tell me. Yes.
Can you go to the Excel sheet?
Yes.
Excel.
This is Excel only,
Yeah. Now here, if you see on in second row, you have mentioned the linear regression with the formula.
Correct.
Okay. And you have evaluated the right hand side, you got the value 13.2.
Yes.
This entire value you are considering as B0. Okay.
No, wait. This entire value is the right hand side of equation. It is not B0. It is B0 plus B1 x1. So if you look at this, B0 is 2 plus B1 times x1 plus B2 times x3 plus B3 times x3. That's what I have. If you look at the equation, it is a sum product of it is basically the right hand side. This entire thing is nothing but the right hand side of linear regression model. That's why I'm writing here. Yeah.
After evaluation, you are getting 13.2.
Yes.
That is the entire right hand side value.
Exactly. I'm writing here clearly a right hand side of equation 1 will be 13.2. To that right hand side, just put a negative sign and then pass it through the exponential function. Add 1 to the exponential function and then take the reciprocal. You'll have a number which is between 0 and 1. So these are the mathematics. Nobody expects you to remember the mathematics. All that you need to remember is that there is a S-shaped function, and that S-shaped function, correct? Let me just show this S-shaped function again. This S-shaped curve is called as the sigmoid curve. This is the S-shaped curve. So why should I remember this? Because you put the RHS of linear regression model into this S-shaped curve, it will always give a value which is between 0 and 1. You can put 13 million, 40, minus 40, anything. The output will always be between 0 and 1. So why should the output be between 0 and 1? Because my outcome variable in a logistic regression model is whether the person will churn or not. I can't have a value of 13.2. We are not predicting housing price here. We are predicting whether the price is high or low, whether a person will suffer from cancer or not. So you can't have 30, 30,000, 40, 50. Those scale outcomes are not allowed here. So I want an outcome which is between 0 and 1. The output cannot be greater than 1. The output cannot be smaller than 0. So what I'm doing is I'm using this S-shaped curve. And in this S-shaped curve, I'm passing the right-hand side of linear regression model. The moment you pass this, pass the right-hand side, it can be any number. The output will always be between 0 and 1. So my job is done. As you just now saw, 13.2. If I just push it into the sigmoid function, I'm getting the output as 0.99. 99.99 means there is a 99% chance that the person is likely to suffer from tumor, which is why I'm just calling him as 1. That is what we are doing in the case of logistic regression model. So far, it's clear?
Yes, sir.
Yes. Just remember only two things. In the case of a logistic regression model, we have to use a S-shaped curve. Why should we use a S-shaped curve? Because a S-shaped curve will always take, look at the y-axis, the outcome will always lie between 0 and 1. If this one point, if you can remember, your understanding of logistic regression is done. Why can't I use a straight line? If you use a straight line, you can take the output will lie between minus infinity and plus infinity. Okay, so mathematical form I've just now shown. Just for your understanding, I'm showing this. Nobody needs to remember this. Shall we take this to the next slide?
Yes.
So fundamentally, please follow this output. I think this will give you more clarity. What is the difference between linear regression and logistic regression? In the case of linear regression, you can see here this line. It can go down, it can go up till it can touch the sky, or it can just hit the rock bottom, which means that there is no limit to y, right? Housing price can be $21,000, or it can be $50,000, or it can be 1 million or 2 million, 30 million. There is no restriction for the outcome variable in the case of linear regression. Therefore, I can use a straight line equation. But in the case of logistic regression, my outcome is fixed as either 1 or 0. So there is no point using a straight line equation. We are using a S-shaped curve. What is the beauty of this S-shaped curve? It predicts y in such a way that my y lies between 0 and 1 only. It does not allow the value to go beyond 1. It does not allow the value to come less than 0. This is the fundamental difference between your linear regression and logistic regression model. This is the geometry that I'm showing, which is working at the back end.
And talking about the application of sigmoid model, so can you also throw some light on that?
Yes. So in BFSI sector, I spent particularly BFSI, banking, finance, services, and insurance. I spent around 2 years building response model, campaign response models. Campaign response models in the sense, when I'm sending a campaign, right, I can send a direct mailing campaign, right? In UK and such things, we used to send a direct mailing campaign to people to renew their insurance. So when I'm sending a direct mailing campaign, there are only two possibilities. Either a person responds or he does not respond. So in this case, can I use a linear regression model? No, the outcome variable is just response, yes or no. Either you'll respond or not. That's it. Many times in bank, either you'll pay the loan or not. Only two outcomes. Cancer, logistic. Whether a person has cancer or he does not have. There is no third possibility. Sir, I have 50% cancer. I'm 50% fraud. I'm 40% defaulter. That business is not there, right? Yes or no. Yes or no. Or defaulter versus non-defaulter. For any of these problems, you can use a binary logistic regression model. Is this clear?
Yes. Yes.
Now, 5 important points that you need to keep in mind, which are the differences between linear regression and logistic. Very first point is, it is used to predict the dependent output based on independent input variable. In the case of logistic regression, it is used to classify a dependent output. Here we are predicting a dependent output. In the case of logistic, we are classifying. Let's look at the second point. Accuracy is measured using the least square estimation. Yesterday I told you OLS, ordinary least squares method, is used. In the case of logistic regression, we don't use OLS. We are using what is called as MLE, maximum likelihood estimation. This is nothing but a mathematical formulation which is used as the backend. You don't need to keep in mind. Now here, in the case of a linear regression model, the best fitting line is a straight line. In the case of logistic regression, you saw that the best fitting line is a S-shaped curve, which is popularly called as a sigmoid function. This is the third point. Fourth point is that the output is a predicted integer value. Yesterday, when you predicted the housing price, as I told you, the predicted housing price can be 5, 6, 7, 7.5, 8.5, 9.5, 19.5, it can be anything. Here the output is a binary value between 0 and 1 only. See, though linear regression is the foundation of all techniques, but in a real-time scenario, when you're doing applications, logistic regression is the one which is more popular than linear regression because it has a wide variety of applications. Just now I was talking about healthcare, whether a person suffers from cancer or not. In telecommunication, whether you're going to churn or whether you're going to stay, whether you're going to respond to a mailing campaign or not. All these are wide applications of logistic regression model. Where is it used? Linear regression is used mainly for sales forecasting, business and stock prediction and statistics. In the case of logistic regression, it is used for classification, image processing, so on and so forth. So far, are we clear?
Yes. So basically in data mining, hello.
Yes, please. I'm listening, sir. Please listen.
So yeah, so we are using normalization. Somebody has asked the question that what we are doing in this logistic regression to bring the value between 0 to 1. Is it same as normalization?
Yes, it's the same as normalization, but there is no hard and fast rule that you should normalize the data before using logistic regression.
Right.
You can, if you want to do it, you can do it, but there is no hard and fast rule that you have to go normalize the data.
Okay.
Okay. Now, step-by-step guide. I think you're already familiar. This conceptual map of data model building does not change because I still have the base data, which I'm splitting as 70% and 30%, that is train and test. 70% of the training data is fed into the model, and this will spit out the model prediction, the model output, which is used to score the test data, right? I'll build the model on the training data, apply it on the test data, and I look at the model diagnostic. Here, there is a big mistake, and that big mistake is I'm deliberately making this mistake so that I can correct and tell participants that here I can't use R square. We can't use R square at all because we are not using linear regression model, right? So you can use any of the other metrics, like either you can use an accuracy metric or you can use what is called as recall. You can use what is called as F1 score, or you can use what is called as precision metric. But don't write R square here. R square cannot be used in the case of a logistic regression model. This is a very, very important point that we need to keep in mind, that we cannot use R square as a model evaluation technique because our dependent variable is not scale. The matter ends there. That's it. So far, are we clear?
Yes, sir.
The model performance, you can see here some of the diagnostics. Any of these diagnostics can be used. What is called as ROC curve, receiver operating characteristic curve, F1 score, precision, recall, sensitivity, and PR curve. Right? If you just remember even accuracy and precision, that is good enough. Okay, I'll just explain this, but this is the theoretical part. If you are okay with this, shall I show you practically how to execute a logistic regression model?
Yes.
Okay, I'll just close this output. Okay, I don't need this Excel. I don't need this output, a lot of Excel sheets. Let me show you today's data set, what I'm going to use. Okay. Can you see the data set?
Yes.
This is a new data set which I'll be working on. It is for telecommunications data set, correct? I've got customer ID and such things. Then I've got variables like gender, whether a person is senior citizen, whether he's living with a partner or not. Does he have dependents? What is the tenure? Phone service, what all services that he is using, correct? Phone service, multiple lines, internet service, so on and so forth, correct? Now, what kind of contract is he under? Month to month, paperless billing. How is he making the payment? Either through paperless billing or payment method, or through monthly charges and the total charges. Last variable is what I would like to draw your attention to. This is churn variable. Now, what is the outcome variable that we have? What is the type of the variable? Do you notice anything interesting here?
Binary.
Exactly. So the first customer is not a churner, right? He's still in the system. Second fellow is not a churner. Third fellow, yes, he is a churner. Fourth fellow is not a churner. Next fellow is a churner. Again, the next fellow is a churner, so on and so forth. So some people are not churners, others are churners. Some of them are non-churners, others are churners. So can I use linear regression here?
No.
What should I use
No,
here?
sir. No, sir.
Logistic.
Exactly, because the outcome variable is a binary variable. Therefore, I have to use a binary logistic regression model. I hope this is clear so far.
Yes.
Okay, so let me just open up Jupyter Notebook. Okay, so this is Jupyter Notebook. You guys are familiar with this? Okay, open up. Let me insert a few cells here so that I can just quickly run the code. Okay. As usual, we have to import a few libraries and such things. Let me quickly grab the code. Okay, I think it look a bit, you'll get confused with the Word document and such things. So I'll just adjust the screen in a particular way. Okay, so new window, I'll just choose the second window and say share. Okay, so you can just focus on this. Okay, I'll just copy paste the code so that I can just reduce the effort. Some libraries I have to import, guys. Yesterday I told you NumPy, Pandas will always be there because one is for numerical calculation, second one is for data manipulation and such things. Scikit-learn is used for your machine learning. And as you can see here, for model diagnostics, I'm just saying sklearn.metrics, import ROC curve, AUC and such things. I'll just explain all these things. Okay. Now, this is about importing some of the necessary packages. Now, in Python, if you want to print multiple statements, you can use this piece of code. Right? Now, for the first time, what I'm going to do is basically, I will be importing the data set. You can see here, this is the data set. I can just type df.head of. Can you see this data set, everybody? You see this data set? Hello, are you able to hear me?
Yes, we can hear you.
Yeah, so this is the preview of the data set. So far, what I've done is to load the data set. You can see here 5 rows and 21 columns are there, right? Now comes the hard part, right? Some of the things that we can do here, right? Let me explore the data. How do we explore the data? Some important commands are there, like you can just type df.shape. So what is the sample size? 7043 samples are there, 21 columns are there. What is the type of this particular object? You can see here, I have to run type of df, and it says that we have a data frame. Next is, what is the size of this data set? So you can just say df.size, and then you can just look at the preview, which we have already done, df.head of, right? Head will give you the top 5 rows, and if you type tail, it will give you the last 5 rows. So at a very high level, we can just do this level of analysis, right? We can just study these records to see how the data set looks like. Okay. Now we have to prepare the data. Therefore, what I want to do is check for the missing values. I would like to check for missing values. You can just say pd dot is null of df, which means in this data set, are there any missing cases? So you can just see here false, 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 and false, which means that our data does not have any missing cases. Nextly, when you take a sum of, you can see here for each of the 21 columns, customer ID, gender, the aggregate of the missing cases is 0, which means that I don't have any missing cases. So far, are we clear?
Yes, sir.
So just take up the is null with any function, sir. Just let me see one time.
So can you come again, sir?
Sir, the first function, sir, pd dot is null dot any function. That output I wanted to see.
This is the output, sir.
Is it giving like any missing value? It is false, means there are no missing data.
Yes, yes.
Okay.
It has checked all the cells in customer ID, and it has not found one single missing case.
Okay, sir. Thank you.
It is just giving you a Boolean output, true or false. So far, it's clear. Now I'll just make a move on. Okay. Now, what we can do is basically we can run the next command, very important, df.info. Info is very, very important. Please see here, for each variable, it is displaying the non-null count, which means that there are 7,043 non-missing cases. And then data type is basically given as object. So you may ask me a question, what is an object data type? Object simply means it's either a string or a categorical output. It's either string or categorical in the below output, right? I say it's either a string or it is a categorical output. This is what it means. Okay. Now, before we get into the next level of analysis, so far, are you clear? Are you able to understand what I'm doing? We have just checked the data type. We have checked the shape of the data set. Are there any missing cases? Which one is an object data type? Which one is not an object data type? So you can see some of the cases are like float and such things, which is good. Correct? So far, are you clear with what we are talking about?
Sir, for integer and float, why it is giving 64?
For integer and float?
Why it is showing 64?
It is a byte size, whether it is 32 byte or 64 byte. Now, I would like to take your attention back to the data set. Correct? Can you see the data set? Are you able to see the data set?
Yes, yes.
So this is an interesting data set because, and it's also slightly complex data set. Yesterday, when we worked on the crime data set, all the independent variables were numeric, so we did not have to polish the data set. We did not have to do much of data cleaning. Now here, this is not such a straightforward data set. Look at customer ID. This variable needs to be dropped because ID, social security number, Aadhaar card number, telephone number, that cannot be used for modeling.
Mithun, I believe we are not able to see the your data set because the now
Data set is visible.
Here I see only the
now it is not visible.
Now it is not visible.
I'm showing the Excel data set.
It is visible now.
Okay.
It's visible now. Yeah, it's visible.
Okay, great, fantastic. So customer ID is not a useful variable for modeling. So I have to remove this. This is one of the action that I need to take. Please look at some of the variables like gender, right? Now here, this is a slightly tricky variable. Why do I say it's tricky? Because it is string. And in machine learning models, we can't use string data at all. String is very, very problematic. So we can't use any of this string data, and we have a lot of string data, yes, no, and such things. So what we need to do is convert them into numbers. Correct? If you look at senior citizen, 0 and 1 is there. That's a good variable because you can feed the variable. Machines understand numbers; they don't understand string. Tenure is also okay, not a problem, right? So effectively, you have got one numeric variable. Tenure is the second numeric variable. And then you can see here monthly charges and total charges. This is also a numeric variable. So this I like to highlight using a different color. When it comes to contract, paperless billing, and such things, they're again string data. It's a bit of a problem. So you can see here our dependent variable is no or yes, which is again string, which has to be converted to numbers. Monthly charges and total charges are anyway numbers, so don't have to worry about it. And all these columns which are in blue, basically they are string data, right? It is categorical, it's object data type. It's a bit of a problem. You can't use it for modeling. So all these are problems. So string data has to be converted to numbers. So that will be the next course of action. So far, are you able to understand what I'm saying?
Yes.
So how many numeric variables you have? Senior citizen and tenure, which is 2. And monthly charges and total charges, that is 3 and 4. So totally you have 4 numeric variables. Do you agree?
Yeah.
So I've got 4 numeric variable. Okay. Now let me just go back to my PowerPoint. I'll freeze one window so that you don't get confused. You can just look at this. Okay. So this is the data set that I have. Fine. Let me just go ahead with the next code. Now, if you remember, yesterday I ran a describe function. You can see here, describe is correct, is giving the output for numeric variables only, because count, mean, standard deviation, all these things work for, all these things are relevant. All these things are applicable for scale data, not for categorical data. Senior citizen, tenure, and monthly charges. Now, this is where there is a bit of a problem. You can see here, there are three numeric variables, right? But if you look at the earlier code, we said there are 4 numeric variables, correct? Which are the 4 numeric variables? Senior citizen, it is recognized properly. Fantastic. Tenure is an integer variable. Fantastic, it has recognized properly. Now, monthly charges is a float variable. That is also proper. The problem comes with total charges, which is recognized as an object data type. It is a categorical. Right? Python is considering this as object, but is it really object data type? I want to ask this question of my audience.
No, sir.
That is a bit of a problem. That is a bit of a problem, correct? So let us go back to the data set. Let us just take a look at the last variable, that is total charges, correct? Total charges is recognized as what? Object data type.
Object.
Right? So what I'll do is basically I will go to data menu and put a filter here. And then look at total charges. Can you see here? When you see here at the last row, there are blank cases. Do you recognize this?
Yes.
Which means there are missing cases in the data set. Right? So because
but it was not showing.
Yes, that is a problem with Python, that it can't recognize this. I'll just tell you what is the problem. So when you look at total charges, there are so many missing cases. At least 8 different cases are missing. Now, because of these blank cases, total charges is getting treated as an object data type.
Right.
So missing cases and such things, missing cases in Python, when you say is.null of and such things, that is applicable when the variable is numeric. But this variable is first of all not being understood or comprehended as a numeric variable by Python in the first place, because there are blank cases here. Because there are blank cases here, it is being treated as object, and because there are because it is treated as an object, that pd.is null of is not reflecting the right number of missing cases. Ideally speaking, it should have returned as 8, but it is not returning as 8. So this is a big problem. So we have to take care of this problem. So far, is it clear?
Yes.
So let's just work step by step into this. I just can please put yourself on mute? Can you kindly put yourself on mute? Somebody is speaking. Can you please?
5 है, इधर 5 है,
Can you please
सामने
put
वाला
yourself on mute?
7 है, सामने वाला 6 होता
Can you put yourself on mute, please?
है। तो चल आजा, हाँ? उसको ले जा।
कर देता हूँ, कर दिया मैं।
Yes. Okay. Okay, missing values is a problem. Now, what we have to do is basically missing value imputation, correct? Now, when I do a missing value imputation, look at this, you'll get an error. So what am I doing? I'm saying, boss, you go to total charges and fill NA with the mean value. But Python starts abusing me. It says, boss, value error. It says this mean value and such things will not work at all. Why it will not work? Because mean is applicable for numeric. This variable is not at all numeric in the first place, it's saying. First treat this as numeric, and therefore then you can apply mean. So that is a problem which we are trying to address here, right? So what I'll do at this stage is, right, I will forcefully convert this variable into numeric, right? Right, I will just forcefully convert this variable to numeric. Total charges is a problem. So pd.to_numeric, right? We are forcefully converting this into numeric. Errors is equal to coarse, correct? So now that it is being coursed into, it is being coursed as numeric. Now let me try to impute it as with mean. So once it is treated as mean, you can see here the error vanishes. So first thing, when you encounter an object data type and there are missing cases in there, forcefully convert this into numeric. Then you can use the mean value imputation. So far it is clear?
Yes.
Now, if I type df.info, you can see here df.info total charges is being read as float. Correct? This is what we have been able to achieve. So far, is it clear?
Yes.
Right. Just 1 second. I'll just show you only one window, which is my Jupyter notebook, just to avoid confusion, and you can just focus on only one window rather than me changing it multiple times. Okay. Now we have checked the data type. Now let me just rerun this describe function. Now you can see here there are 4 variables for which it is displaying mean, sum, and so on and so forth. Earlier, it was displaying only for 3 variables, namely senior citizen, tenure, and monthly charges. Right? So which means that more or less now you're on the right track. Correct? So this is one change that we can do. Nextly, very important concept that I want to do is basically identify class imbalance issue. Right? So these are all some of the things that we need to check whether there is class imbalance or not in the data set. What is this class imbalance issue? Let me just look at we are building a model for churn. Correct? Churners are there. 1869 churners are there. In the data set, 1869 are churners, but 5074, 174 are non-churners. Right? So if you look at the proportion of churners, it is 1869 divided by the entire sample size of 7043. Right? So when you look at this, 26%, 0.26 means 26% of the data has churners. So why am I doing this? See, look at this problem from a larger perspective. Many times, forget churn, right? Many times, let us say we are trying to model COVID infections, right? Just giving an example of COVID infection. I want to identify the profile of those people who have been infected. Correct? But in the nation of 140 crore people, right? The non-infected cases may be more, infected cases may be very less. So 1% of the people may be infected, 99% of the people may be not infected. So this is what is called as class imbalance issue, which means that the dominant 99% of the class is healthy population. Correct? 1% of the people, a tiny minority of people are the ones who are infected. But this tiny minority, their behavior is more important to me than the harmless majority, which is 99% of the people. Correct? Same way, when you are trying to predict a binary class, one of the classes will be of important to you. I said fraud and genuine customer. Genuine customer is not genuine customer is harmless to me. He is not doing any genuine customer. Sorry, is harmless to me. He is not causing any harm, so I'm not bothered. I am bothered about fraud cases. I am bothered about default cases, not non-defaulters. I am bothered about tumorous cases, not non-tumorous cases. The same way here, the class of interest is churner. He's going to leave. So I am actually interested in the yes category. Their proportion is 26%. Tomorrow, if you're working on a different data set, and if you were to get the proportion of churners as less than 1% or let's say 2%, and you're trying to build a model, just think you're giving only 2% data and you're expecting the model to learn the characteristics of churners based on only 2% or 3%. Can a model be developed for only based on only 2%? No. The model will exactly do the opposite. The model will learn the characteristics of 98% of people, not the 2% of people. So this is the biggest problem of any classification model, that is what is called as identifying class imbalance. So if the category of your interest is in a hopeless minority, 1%, 2%, and 3%, there is no point building a model, because a model cannot be built. The model will not get trained in identifying the characteristics of churners. The model will understand the characteristics of non-churners, because 98% of the category, 98% of the people are non-churners. Here, however, it is decent. In this data set, 26% of the people are churners, which is a decent sample size. It is not a well-balanced data set, but nevertheless, I am expecting the model to still go ahead and learn certain characteristics. So far, is it clear as to what we are talking about? Are you able to understand?
Yes, yes.
Yes, sir.
So this is a very important step. So that's why I'm just explaining this in detail. Class imbalance is there or not. So though there is class imbalance, it is not a big imbalance, right? I think our model should still do a good job. Now, the first data prep that we have to do is convert this yes, no into 0 and 1. Converting churn from yes, no to 0 and 1, which means basically we are converting string to numeric. Correct? We are converting string to numeric here. So you can see here, finally, I'm just saving this as y, which is 0 and 1. Correct? So let me just show you here how it works. df.head of in the end, if I just scroll down, you can see here I've created y here. Wherever no is there, it is recoded as 0. Wherever yes is there, it is coded as 1. Why? Because machines simply understand numbers. Machine cannot understand no and yes. You and I as human beings can understand alphabets and words, but machines cannot understand. So we have to convert this into 0 and 1. So what is the next step? Dependent variable we have taken care of, correct? The next step is basically we will be separating out the independent categorical variables for conversion into numeric. So we identified that out of 21 variables, there were many variables which were string data. So you can see here, I'm separating the numerical and non-numeric data. Why are you doing this, sir? Because I want to convert all the string data into numeric. Gender, if you recall in the data set, it is marked as female and male, correct? Partner, yes or no. Dependents, yes or no. So all these variables are categorical. They need to be converted into numerical. This is what we are doing. So far, are we clear?
Yes.
Correct. This is what we will be doing. Okay. So firstly, let me isolate all the categorical variables. Next step is to basically display the top 5 rows. Now, what do I have in this x underscore categorical? You can see here each and every variable is only string. You have eliminated the numeric variables because now wholesale for all these variables, I can apply and basically convert them into numeric. So let me just quickly check the shape of this data set. You have 15 columns and 7043, which is the sample size. Now, for these 15 columns, what we are going to do is basically, right, we will now separate the, let us just keep that aside. Let us also separate the numeric variables. So senior citizen, tenure, monthly charges and total charges were all numeric variables. Okay, so you can
I think
Uh, Shukla sir.
Yes, sir. Yeah.
I will take care to mute the participant if anyone is going to make
Right,
their
right.
mic on. Huh?
Right, sir. Right, sir. Yes, yes.
I will take care. Ask sir to continue without anybody.
Right, right. Sir. Yeah, yeah.
Okay.
I think Mithun sir gone on mute. Yeah.
Yeah, he might be gone.
I have unmuted myself.
Mithun sir.
I've unmuted myself. I was not speaking. I'm okay now. Okay.
Okay. Yeah.
Right. Now I've separated the numeric variable and I've separated the categorical variable. Till here, are we clear, everybody? Any questions, please ask.
You are clear, sir. Yeah.
Okay. Now, the question is basically, what is the next step? Let me just put on Control V. pd.get underscore dummies is of x underscore categorical. Now here, when we say x underscore categorical, let us just do firstly x underscore num1. When you convert this into num, so look at this beauty, look at the beauty behind this function. Get underscore dummies. The moment I say get underscore dummies, my original variable will be converted into numeric. So if you look at gender here, basically it has been converted into binary 1010, partner 0101. So this is how you can build a model, right? So earlier your data was all completely string, no, yes, no, yes. Now what have you done? From no, yes, you have made this as 0 and 1. So far, is it clear?
Yes, sir.
Okay. Next step, right? I've got what I wanted, which is to convert string data into numeric. Sir, what is the next step? The next step is basically to get all the x's, which means basically I have to combine the original data, x underscore num. There were 4 numeric data. Now the new data which has been converted after using pd.dummies, both of them I'll concatenate and I will just call it as x. So now if I type x dot head of, what will you get? You can see here the new data will have a combination of gender, partner, dependent, so on and so forth. And finally, you'll also have original data like senior citizen, tenure, monthly charges, and total charges. So you have a combination of both converted variables as well as the original numeric data. So this is all part of data preparation. So far, I've not done any modeling. I'm just telling you how you prepare the data before analysis. Because if the data is in the form of string or character, we can't go ahead and build any model at all. So I hope you're able to understand so far at least. Everybody?
Yes.
Yes. Right. Let me just insert a few. Okay. So what is the next step? Now the next step, so far we have done preparation of the data. Now, one thing that we can do is we can just create the dependent variable. Right? What is the dependent variable? Churn. But instead of churn, I will use y. Y has numeric data, which is 0 and 1. You can see here my y variable, which is the dependent variable, has 0 and 1. Right? Now the same old story. There is no change at all. Now we split the data set. If you remember, training testing we have to create. So therefore, you can see here, same as yesterday, train underscore test underscore split x comma y. Testing I'm using 25% only. There is no specific reason. You can, if you want, you can change it to 30% also. We can use 25% of the data for testing, which automatically means 75% will be used for training. These are all our old friends: train underscore x, test underscore x, train underscore y, test underscore y. So these are the 4 objects that we are going to create. Now, if you want, you can just check the shape of each of these things. Just type train underscore x dot shape SHAPE. Let me just execute this. You can see here 75% of 7043 is 5282, which means correctly approximately 75% of the cases have gone into training data set. Similarly, if you say test underscore X, you can see here the balance 25% of the data for independent variables have gone into test data set. So far, is it clear?
Yes, sir.
Okay. This is my logistic regression model, right? So what I'm going to do is basically, right, from sklearn.linear underscore model, you just import the logistic regression model, right? Now, once you import this, you can just call this as log, right? This instantiating a logistic regression model. Instead of typing the entire word, I'll just be typing log, which is just a short form for logistic regression model. Okay, let me just check once whether my training data set has any missing cases, right? So train underscore X dot is null off. Ideally speaking, you should not have one single missing case. If there is a single missing case, the model will not run. So you can see here 0, 0, 0. There is no missing case at all. So hopefully, when I fit this model, it should run successfully. So let me go ahead and fit a logistic regression model. So this is my logistic regression fit. Train underscore X comma train underscore Y. Now the next step is, just like linear regression, I can just get the coefficients. You can see here, because we have a lot of variables, we are getting a lot of coefficients, just same as linear regression model, correct? But it is not very interpretable because I don't have the feature values. So let me just attach the feature value and then show you corresponding to each variable what is happening. See here, for each variable, you are getting a coefficient value. Are you able to see this? Are you able to see this? This is your coefficient for each variable. Are you able to get this?
Yes.
Correct. Now, one thing which I'd like to sort of highlight here is, see, there is, okay, let me go back to pd.getDummies. Do you see anything happening here? Anything interesting do you see?
Created dummy variables.
You're absolutely right.
Categorical variable they are basically.
Sorry?
They are categorical variable. Whether
Okay.
it's a male, then it's a one is there, and if it is female, then one is there. So it is categorizing the data.
You're right. See, the problem here is when we had originally we had gender only, correct? We had one variable gender, but now because gender has two categories, this pd.getDummies will create two variables, one separately for females and one separately for males. If the first person is a female, it will call as 1, and second variable it will call as 0 because it's not a female. So wherever there are females, it will call as 1. Wherever there are no females, it will call as 0. Similarly for male as well, wherever there are males, it will call as 0, and wherever there are males, it will call as 1, and wherever there is female, it will call as 0. So do you see a problem with this?
Yes, number of columns increase.
Exactly. So this is a big problem, correct? So you have too many variables. This is called as dummy. This is the number of columns will increase. If you have 5 columns, 5 categories in a column, it will give 5 different variables. And this is redundant information, correct? It is not very useful. I know that, if I have only female or only male category, that is sufficient for me. Because if a person is not a female, obviously it means that it is a male. And if a person is a female, it automatically means that it is not a male. So you can use one additional argument here, very useful argument. And that argument is, you can just simply say drop underscore first equals drop underscore first equals false. Right? Okay. Okay. Drop underscore equals false means nothing will come. So let me just say drop the first category. Now you can see here, if there are 2 categories, you can see only one. Male is there. Similarly, for partners also, you have got only one of the variables. That is sufficient for me, because this itself is good enough for me to explain. So this is very important. Drop the first category. Give me the variable for the second one. So what is the benefit of this? You will have a lesser number of columns, which is always manageable. There's no point having too many columns. We will struggle later, right? So having fewer columns is better. So far, did you understand?
Yes.
Right?
Yes.
So instead of having 40, 50 columns, I think it is enough if I have fewer columns, like 20, 25 if I have, it is more than enough. So you can see here.
Sir, I have a question.
Yes, please.
Hello.
Yes, please. Yes.
Suppose for a variable, I have 3, 4 different values. In that case, by using this function,
yes,
I will get 0, 1, 2, 3, 4 likewise. No?
Yes.
Okay.
No, yeah. So if you have, let's say multiple categories, more than one. So if you have 4 categories, it will create 3 variables. That's what will happen. If you have n categories in the variable, you will get n minus 1 variables.
Right.
Is it one hot encoder?
Yeah, you can. One hot encoding also can be used here, but we are not using one hot encoding. We are actually using dummy variables, which is more or less like one hot encoding itself. For image processing and such things, mainly we use one hot encoding and such things. So far, we are clear. We have built the model. We are getting the coefficients. So far, is it clear?
Yes, sir.
Now, is this model good or bad? That is the question. Now, to answer that question, we have to generate certain model diagnostics. What is the overall accuracy of the model? That is what we need to check. So even before that, look at this. In the test data set, there are 1,761 cases. Positive cases are 434 and negative cases are 1,327 cases. Now, let me just look at the accuracy here, right? One of the important metrics here is what is the accuracy. You can see here, overall, our model accuracy is 81%. So 81 out of 100 individuals will be classified correctly. That is what it means. Okay. Okay, let me just show you what is called as a confusion matrix. I'd like to show you what is called as confusion matrix. So are you able to see these numbers? This is called as a confusion matrix. Are you able to see this number?
Right. Yes.
Yes, sir.
Okay. So how many numbers you're able to see? 4 numbers, correct?
Okay.
So we are building a model here, right? Model's job is to basically identify whether a person will churn or not. Look at this. There are 4 categories. I'll just show the same thing in Excel. I think you'll be able to understand this better. So right. So you have churn category and non-churn category. This I'm going to call as actual category. Actual means basically in the data set, they are actually churners. I hope you are able to see my Excel sheet. Are you able to understand this?
Yes, correctly classified.
Yes. So what we have is basically actually a person is a churner and the model is also correctly calling him as a churner. Similarly, what we want is basically predicted churn. Right? How many of these people have been predicted as churners and non-churners? So along the row, you have actual group, and along the column, what you have is basically the predicted group. So actual group is one thing, predicted group is another thing. Correct? Now, these numbers, I will just read from Python itself. What is the number that you are getting? True 0. 0 means non-churn here. And predicted is 0. Look at this. How many such cases are there?
1194.
Yes. So 0 means basically non-churners. The coding for non-churners is this thing. So it is 1194. Now let's look at the other category. True predicted as 1 and actually is 1. How many cases are there? 240. Do you agree? Correct. 1 means basically he is a churner. He is actually a churner and he is also predicted as churner. 240 cases are there. Look at the row here. True is 1. True 1 means basically 1 is the notation. It is a numerical value for your churn category. And 194 is basically is predicted as he is actually a churner, but the model is predicting him as a non-churner. So how many such cases are there? 194. Let me go back to Excel. Actually, a churner predicted as non-churners 194. And the last number we have is basically 133. So these same numbers, whatever there was there in Python, I'm just putting this under in Excel. So far, is it clear? I'm just copy pasting this.
Yes.
Okay. Now there are certain terminologies that we need to learn here. Correct? When the actual is churn and the predicted is churn, this is called as true positive. True positive means actually the person is churner and the model is truly identifying him as a churner. Similarly, 11,094. Can you guess what this could be? What can we call this?
True negative.
Very good. This is called as true negative. Right? So the diagonal elements here represent the correct classification. Correct? Because actual and predicted categories match, it is called as the correct classification. And the off diagonal elements are the incorrect classification. Are you able to understand this?
Yes.
Okay. So what can we call 194? There are 194 customers who are actually churners, but the model has predicted them as non-churners. Ulta, it is not able to understand this. So this is a misclassification.
False.
What name can we?
False positive.
Very good.
False
False
positive.
positive.
False.
False positive.
No, false negative, right?
Yeah, false.
False negative. And what about 133?
False
Is
positive.
false positive. Are you clear with this?
Yes.
Right. So this is what we have. Sir, why are you showing all these things? From this table, we can calculate the accuracy. Correct? So what is the true positive number that we have? 240. Do you agree?
Yes.
What is the false negative number that we have?
190.
194. What is the false, false positive is 190. False negative is 194. What is false positive? How many cases we have?
133.
133. And what about the true negative?
1194.
1194. What is the overall sample size? I should add up all of these things.
Yeah, very sure.
Right? Equals just sum of all of these cells. Is 1761. Right? Now just take a look at this. This is important because from this, I can actually calculate the overall accuracy of the model. Overall accuracy of the model is whatever I've highlighted in yellow color, because this is a true classification, correct? Which is nothing but 240 plus 1194 divided by the sample size. The sample size is 1761, correct? So 240 plus 1194, the true classification divided by overall sample size. Are you able to understand accuracy, how we are getting?
Yes.
This is how accuracy is calculated. So far, is it clear?
Yes.
Yes, sir. Yes, sir. It's clear.
So far, it's clear. Any questions, please ask. So this is how the overall accuracy of the model can be obtained using logistic regression model. Right here, I'm not talking about any other metric like R square and such things. You can look at accuracy. That is a good enough job. So any questions? So with this, you have generated the coefficients. We have built the logistic regression model. We can also look at the overall statistics. Any questions, please ask me. So far, any questions?
Hello, sir. Am I audible?
Yes, sir. Yes.
Sir, false negative is a problem, right? How
Yes.
to reduce the false negative and false positive?
Yes. So false negative is a problem. In some cases, false positive is also a problem. Right? So here we are looking at accuracy, correct? So over and above accuracy, there is another metric which is called as precision metric, correct? So you can look at what is called as precision. Precision, there is a formula which is called as TP divided by TP plus FP. Look at this, TP divided by TP plus FP. All are P. P for precision, TP divided by TP plus FP. So instead of looking at accuracy, it is better to look at, sometimes better to look at your precision metric. Look at TP. What is the TP value? 240 divided by TP plus FP is 240 plus FP, which is 133. So your precision of the model is basically How much? 64% only. Are you able to understand this? How
Yes,
precise the model is? It is 64% only.
Yes.
Correct? Out of the total predicted as positive, your model is accurate only 64 out of 100 times. Baki ka 36% is a problem. So here, can you see this very important thing, FP? FP is in the denominator, correct? Do you agree? In the formula.
Yes.
So wherever false positive is a concern to you in whichever study, use precision. Because if the false positives are high, overall precision will come down. Denominator has a inverse relationship, correct? If you increase the denominator, overall quantity will come down. If you decrease the denominator, overall quantity will go up. That is a simple relationship that we're using. False positive. In manufacturing sector and such things, precision is looked at. Why do we look at precision? Let us say false positive. Let us say I'm manufacturing a mobile phone. There are 10,000 mobile phones I'm manufacturing. Actually it is a good mobile phone, but my staff members are not trained properly. So though the mobile phones are good, they basically put it in the dustbin saying that it is bad. There is some defective. This is not working. That is not working, and such things. So here it is a case of false positive. Falsely, the person is saying that it is a defective item when it is actually not defective. So here, false positive needs to be punished. If the higher the false positive, precision will go down. So in manufacturing sector, this becomes a problem. Now let's look at recall. Recall is what? Everything is the same. It is TP divided by, you have TP plus Fn. TP divided by TP plus Fn. So what we can do here is, your TP is 240 divided by TP plus Fn, which is 240 plus false negative is, so your recall metric is how much? Only 55%. Are you able to understand what is the change here? The change here is I'm using false negative. False negative, correct? So when is false negative important? Can you think of an example? In some cases, false negative, in some studies, false negatives become very important. Can you just think of an example?
In cancer prediction?
Very good. In any healthcare and such things, recall is looked at. You know why? Because false negative means what? False negative. Let us say a person is actually suffering from a disease. He is positive. He has COVID or he has cancer. But your model is saying, no, 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 he's healthy. Falsely, it is saying that it is negative. There is no problem at all. If your model is saying that he is negative, which means that basically he will not be given the treatment at all. You're depriving the patient of treatment, which means basically you're pushing him closer to death. So here in healthcare and such things, we want the false negatives to be really, really less. If the false negatives are higher, recall will go down. If the false negatives are lower, recall will go up. So there's an inverse relationship. So it depends upon what do you want. In healthcare, medical, pharmaceutical companies, recall is used. In manufacturing sector and such things, precision is used. If you don't have any preference, use accuracy. So this is how you can evaluate the model diagnostics. Any questions so far? Any questions so far? Were you able to understand what is logistic regression? What is the sigmoid function? What is the difference between linear and logistic regression model? How we prepare the data, string data, it has to be converted to numeric. So we use dummies. How do you identify missing cases? How do you impute with mean, right? What is the meaning of an object variable? How do you convert an object into numeric, right? That is a data preparation. Then we use logistic regression model. I showed you the mathematical form, and then we can generate the coefficients and look at the quality of prediction. We have studied 3 metrics: accuracy, precision, and recall. Is it clear to you? Are you able to understand? Are you able to follow, please? Any questions, please ask. Please feel free to ask.
Sir.
Yes, sir. Please tell me.
Yes, sir. I have read one another accuracy score, that is F1 score. What does it F1?
Good question. F1 score. Okay. Let me go to this Excel sheet. So you have accuracy, precision, and recall, correct?
Yes, sir.
Yes. So there is a third metric, which is nothing but the harmonic mean of precision and recall, which is called as F1 score. F1 is nothing but 2 times PR divided by P plus R, right? PR by P plus R, which is nothing but the harmonic mean, which means take 2, multiply it by precision. Precision is 0.64. Multiply it by R. R is nothing but recall, divided by P plus R. P is nothing but 0.64 plus recall, which is nothing but 0.55. If you do this, the overall F1 score is 0.59. If you round it off, it should be 60%. So this is used when the data has class imbalance issue. You can use F1 score.
Yes, I understand. Thank you.
Okay. Any questions, please ask me. Can logistic regression be applied to continuous variables instead of categorical variables? Answer is no. I think Ankit sir is asking, can logistic regression be applied to continuous data?
Yes, sir. Yes, sir.
We can't directly apply it to continuous data, but there is a trick that we can do. What is the trick? Let us say yesterday we had the variable housing price, correct? My dependent variable was housing price. Do you recall?
Yes, sir. Yes, sir.
So that's a continuous data. I can't directly apply logistic regression there because it is not categorical. But what is the trick? Based on the housing price, can I categorize the homes as low price and high price? I can say from 0 to 50, if the housing price is less than 50, it is low. Greater than 50, it is high. So now I have converted a continuous variable to a dichotomous variable, low and high. Now I can apply logistic regression.
Sir,
so all yes.
One more
sorry.
question, that we have to create every time dummy variable whenever there is a categorical data?
You have to create dummy variables when you have string independent variable.
Okay.
String independent variable.
Okay, okay. Means if there is a numerical variable in category, then we don't have to apply for that.
Exactly. Senior citizen in this case, in our data, senior citizen was the numeric variable 0 and 1. I don't have to apply dummy because it is already numeric. Why should I again convert it to the numeric?
Okay.
On the other hand, gender is a string variable. It's a character variable with 0 and 1. For this variable to convert it into numeric, I'll be applying dummies.
Yes.
So any other questions, please ask me.
So I have another question.
Yes, please.
So here you said that the dependent variable is decent balanced. So what if the data has an imbalanced data set? Then how to work on that kind of?
Very good question. So if the dependent variable has imbalance, then there is a technique called as SMOT, S-M-O-T-E. S-M-O-T-E, S-M-O-T-E. You have to use this technique first and then apply logistic regression model. SMOT stands for synthetic minority oversampling technique, which means that basically when there is class imbalance, there is one category which is less 1%. So it will try to boost up 1% to, let's say, 10% or 20%. After boosting this or improving the minority class, then basically we can run a model. That is called a SMOT technique.
Okay, thank you.
You can look at this in, yes.
If our data is y variable is having actually multi-class, then can logistic regression be applied in any case?
Yes, you can use, but you have to use a different form of logistic regression, which is called as multinomial logistic regression. Do not use binary logistic regression.
And is it available in Python? Because
yes, everything is available in Python. But my advice to you is don't use multinomial logistic regression because you can use it. Theoretically speaking, you can use it. But the output that you get will not be straightforward and easily interpretable.
Okay.
So my suggestion to you is instead of using multinomial logistic regression model, you can use another alternative technique for multi-class problem. Multi-class means basically if the dependent variable has more than two categories.
Yes.
Here in today's example, we had 0 and 1, whether a person will churn or not, which is called as a binary class. You are asking when I have got multiple classes, more than 2, that is 3, 4, 5 class. So when you have a multi-class problem, please use decision tree. It's a lot easier to use. It's a lot easier to apply and interpret.
Okay.
So the short answer is multinomial logistic regression can be applied. However, don't apply it because it is hard to understand, interpret the output. Instead of using multinomial logistic regression, a better approach is to use decision tree, which I will be covering tomorrow.
Okay, sir. Thank you.
Thank you. Okay, any questions? So can you use real-time examples? All these examples which I'm giving are all real-time examples. Churn prediction, which is extensively used in telecom sector, right? Gene prediction, right? I think I have shown one example. Let me just, in my videos, right? Cancer prediction also I have done. So here the outlier 73. Here one problem on cancer prediction I think I have done. SVM. You can see here predicting cancer patients. Correct? So this is also an example that you can look at. So it's basically you can just take a look at this. So I'm just sharing the link with you, right? So how do you predict cancer patients? So to predict cancer, tumor, health, COVID infections and such things, extensively logistic regression can be used. So that is one real-time example. I'm pasting the link here. You can just please click on this and you can use this. Any other questions?
Mithun sir, what is this rule of 10 in logistic regression model?
Rule of 10, sir?
Yeah, yeah.
I don't know, sir, to be honest. I've not heard of it.
Okay, okay.
I've heard of what is called as decile banding,
Okay.
but not rule of 10. I don't know directly.
No, it is said something like thumb rule, let's say, and so just we.
No, maybe I can just search and tell you tomorrow, sir.
Okay, okay, sir. Okay.
Okay. Otherwise, I've not heard of rule of 10. Okay. So, any questions if you have, please ask me. There's a lot of rain in Bangalore, so I think the power may sort of be off.
Okay. Achha, today also it's raining there?
Yeah, heavily, sir, heavily.
Oh my God, yeah.
We are it's almost, driving is almost, we're not driving, we're sailing, sir.
Okay. In Pune also it was rain, but that was in afternoon. Now it is clear. So.
Okay. Here evening.
Do you stay at like Varthur Lake side?
Yes, sir. Tell me, sir.
Do you stay at Varthur Lake side in Bangalore?
Yes, sir. Close to it. Yes.
Okay.
We up to the knees. Basically, we see water, sir.
Okay.
So that is a problem.
It is overflowing.
It's overflowing, sir. Overflowing. It is overflowing, and they've made it worse because they have dug holes, potholes, and all. So people cannot see whether it's a pothole, whether it's a proper road. We don't know what is it. So, so many times for the car and all, people are removing the battery because the water has almost entered the battery also.
Oh, yes.
It is Bangalore is not a very planned city, sir. That is a problem.
That is true. Yeah.
And in South, basically, we never had a good visionary leader. For the last 30, 40 years, we don't have visionary leaders.
But the intellect comes mostly from South.
Yes.
Certain places.
Yes, but leaders, they're intelligent to the extent of their career, not in choosing leaders.
Okay. Yeah. So, if any more questions, I think the participants can
ask.
Oh yeah.
Yes. Yesterday and today we mostly covered linear regression or linear models and such things. Otherwise, if there are no questions, tomorrow what we'll do is basically we'll move on to non-linear models. A couple of interesting models I can just show you, so that how non-linear models can be used, that we can just discuss. So the goal mainly when I came here today, yesterday I just gave a simple example, not much of data cleaning and such things, just simple heat map, coefficient, p-value, so on and so forth. Today I took a slightly complicated example in terms of complicated in the sense of data preparation and such things. Real-time data, when you have, it will be messy. It will not be so easy. It will be messy. It will be difficult. It is not so straightforward. String data will be there. Missing cases will be there. How to handle this? That is the emphasis. Tomorrow I'll be talking about decision tree. And if possible, if time permits, I can introduce one more algorithm a priori. So that is the goal that I have as far as tomorrow's concerned, right? So 2 days of supervised learning technique. Tomorrow, I will just again show you one supervised learning technique. Then slowly third and fourth day, mostly in the fourth day, I'll talk about one unsupervised learning technique. Any questions, please? I've already shared my number. If you have any questions, problems, please feel free to WhatsApp me. If I know the answer, I'll get back to you. I will anyway share these PPT and quotes with sir. I think sir can sort of circulate it in the larger group.
Yeah.
My request to you is actually you can make a WhatsApp group with all the participants.
No, we have already made it. We can also add you there. So
please add me, sir.
Yeah, I will add you there. so
Yes,
that
yes.
they can also ask in case of any question, they can get connected.
Definitely, yeah. We can keep it very interactive. We don't have to sort of limit it ourselves to just 2 hours.
Yeah.
We can obviously, sir, this code is there. If I have, I can obviously come back.
Even later also like that, because that group will exist. So later also when they're practicing, so they can take your guidance.
Right. Right.
And like once this model is ready, so normally when we see in the different robots are made and they perform the certain activities, so then how do they simulate the different that model and then the different actions? So can you throw some light on that, the new generation robots which we see for the different activities in the industries and all?
Yes, so we are now, when we say simulation is another different situation altogether.
Okay.
So within a simulation, basically there are different scenarios that are created, and based on different scenarios, we can basically sort of generate a mathematical model to predict the output. So simulation, in the sense, there are at a very low level, there are multiple ways of simulation. One is what is called as MCMC, Markov chain Monte Carlo simulation, which is popularly used.
Okay.
Markov chain Monte Carlo simulation. These days, there are other non-linear methods called as non-linear GRG method or evolutionary method and such things, wherein based on different simulations or different circumstances, we can just basically if given these inputs, what is the expected output? If the input changes, what is further the output? Let me just show you one small toy example of it so that maybe you can understand.
Okay.
Are you able to see the screen?
Yes, we are able to see.
So here what I've done is basically, you can see that we are trying to find out staff productivity and such things.
Right. Yeah.
So I've taken a test case here, staff performance optimization. I've taken variables like category, right? Which this is for Malaysian airport that I was working in.
Right.
DXC. So which category is he like, into is he into collection of baggage, or is he in the security, or is he a janitor? So job category, gender, distance from home, number of shift changes, modal shift, what's the age of the staff, working since, working experience, what is it, ethnicity, number of hours of work that he has put per day, what's his absenteeism rate, on schedule, whether he's completing or not, overtime, work hours. So these are the different features that I have taken.
Okay.
The test case is basically for John, right? So some of these factors are controllable, others are not controllable. For example, gender and such things, they are not controllable. We can't change it. Age of a person, we can't drastically change it. Correct. Work experience also, to some extent, maybe we can give him experience. Ethnicity and all, we can't change it. So you can see here, I've got rate coefficients, which means basically what I've done a contribution analysis and to say what is the contribution of each of these variables in determining the staff productivity, whether he's a low performer or a high performer. Okay. So for example, if you see some of the red color bars here, which means that they are negatively contributing towards his performance. Distance from home, too many shift changes, what is the average shift, if his age, and basically ethnicity to some extent, and absenteeism rate. All these are negatively influencing. And similarly, other factors like gender, working since, work experience, overtime work experience, all these are positively contributing. Now, you can see here the actual feature value of John is this, which means basically he belongs to the category 1. What's his gender? What's the distance from home? That is 14 kilometers or something. What's his work experience? 36. And then basically number of hours that is work per day. Absenteeism rate is 8%. On schedule completion is 63%. Overtime work hours that he has put is 51. So with these characteristics, his performance score is 51 and we are calling him as low performer.
Okay.
Now what we are saying is for him to become a medium performer, we are saying medium performer and not high performer, because if a person is low, suddenly he can't become a high performer. What we are saying is it's a step-by-step procedure. So for him, from a low performance, if he has to migrate to a medium performer, his score must be at least 75. When can he actually become a medium performer? We are saying that by and large, the distance from home has to be cut down by 57%.
Okay.
This is a simulation. Secondly, absenteeism rate has to be reduced by 13%, and then on schedule completion should go up by 8%. Overtime work hours has to be increased by 150%. So if these characteristics are simulated, then his performance score will improve from 51 to 75, and then he will become a medium performer. So all these things, if you want, let's say tomorrow another person comes and his distance from home is, let's say, 18 kilometers. You can see here these numbers are likely to change from 57%. So 67% he has to cut down. Work experience instead of 36, let us say it is only 30. So look at the percentage of change that he has to put in, his 37%. Correct? And
yes.
Similarly, if you look at on-time schedule, let's say he completes only, let's say 60%. Now, if you look at the percentage change that is expected for him to become a medium performer, it is 13% improvement he has to show. Overtime working hours, basically, let us say it is 0. Now he has to, this is a bit difficult because it is not able to compute. So let us say currently he is able to work only for 1 hour. Correct? So
yes.
his overtime working hours has to go up by 400%. Then he can expect to go to 75%. Currently, his productive state is only 24%.
Okay.
So we can simulate different situations. This is one such thing, but mostly people use, Monte Carlo, Marco chain Monte Carlo simulation. There are other simulation techniques which can be used to simulate situations.
Can we do this similar kind of a simulation with in education also? Maybe that we are having certain students with the low performing, and then
yes.
If we can.
Yes.
So,
if his attendance percentage and such things you can take.
Okay. Okay.
If his attendance goes up, if the on-time completion of the projects go up.
Okay.
If his, let's say, if the number of training hours that we put, the number of tuition hours and such things go up, what is the expected performance? What is the expected change in the performance? That's what we can calculate.
Okay. So in this, like how you have selected that the dependent and independent variables, especially in this case, the Malaysian Airlines. So
dependent variable, because they said we have built 3 POCs for them. First is basically they said identify the contributors of performance.
Okay.
So staff performance, which are the factors which influence staff performance? Then they said do vendor risk analysis. In the third stage, they said given a person's demographic details, on-time schedule completion, can we compute what is the expected performance of such a person? Okay. So that's why we have just in the third stage we have done this. We have used a lot of brainstorming, saying that since this is for airport security, airport baggage and check-in service, we have used our own brainstorming. We have done a lot of brainstorming. We have read a few white papers, and we have also taken the help of the client to come up with these variables, because they were also not sure which variables will influence.
True.
They are also not sure. They are like, if we knew, why would we ask you?
Yes. Same is the case with nowadays, because most of the employees are working hybrid. So I think some research is required to be done, whether on their overall the output, like whether it's like when you are working online, so whether what is the productivity has gone up or down. And
yes,
so,
yes.
So
it can work both ways actually, because in earlier 4 to 5 hours, at least not 4 to hours, at least 3 hours we used to spend in traveling from office to work.
Yeah.
That time is actually saved. So in that way, we are mentally better off at home only.
True.
In that sense. Secondly, basically, is the second way is basically in the name of working. Most of them sometimes do time pass and such things. So
Correct.
it might also go down. You never know.
True. Yes, sir. So yes, sir. So we have already given the PPTs yesterday that whatever the data you have, the code and everything that is circulated. So I think all have I mailed them, so all would have got it and they can practice. Similarly, today also whatever the PPT and the material you want to give it to the participants, so you can send it. We'll pass it on so that they can practice.
Sure, I'll do that, sir. I'll do that.
Yeah.
I can do that, sir.
Right, sir.
I'll share the data set, the codes and such things.
Right.
So that people can participate.
So if anybody want to ask anything, want to say anything now, because we'll be ending up, and I'll request the to attendance also. We can put it in the chat box, so you can mark your attendance also. And if anyone wants to make any remarks or say anything at the end, you are welcome.
Hello.
Yes, please. Go ahead, sir.
Okay. Okay. So as far as the linear regression, logistic regression, its applications are understood. It is a very good coverage, but the one confusion is that some of the places I'm getting the information that we can use the neural network also for this particular regression problem. So if it is the line equations and something like that one, why we require to use the neural network? That is my question actually.
Good question. See, many times what happens is that when we look at linear regression, let us say you run linear regression and R square is very low. R square is very low. Let's say yesterday when we did when we ran that Boston housing price prediction, we got a decent R square of around 78%. Today, in another case, for one of the persons, I was running a CLTV, customer lifetime value model, and I got a R square of 4%. Can you believe it? Linear regression gave me R square of 4%. Now, when I did 4%, what does this mean? It means that there is a non-linear pattern in the data set which is not accounted for by the linear regression model. And therefore, your R square is very less. So when there is an inherent non-linear pattern, linear regression model should not be used. Linear regression model cannot be used. It is advisable that you don't use linear models there. What is the answer? The answer there is basically to use non-linear models like neural network. Neural network is widely regarded as a gold standard when it comes to modeling non-linear data. And therefore, wherever your linear regression models give poor results, it is better to use non-linear models like neural network.
Okay, thank you.
Thank you.
Yes. Anyone else has anything want to say at the end of the day too?
Any questions, please ask me. Any comments?
Yes.
You can also just give a reading on decision tree because tomorrow we'll be doing decision tree. I may be using R instead of Python. I may use R or Google Colab. Maybe in Google Colab also I'll just show so that you have an understanding how you can use Google Colab. We can just see this tomorrow. Yeah.
So for that, the Google Colab, whether you'll be sharing any link for that to download and this thing?
Google Colab, you don't need to download anything.
Okay.
If you have a Google account, Gmail account, you can just easily use it.
Okay.
I'll show you tomorrow how to use it.
Yes. Okay, that will be nice. That will be nice. Yes, sir.
Sir, it is just like Jupyter Notebook. Only thing it is on the Google platform.
Okay, that's nice.
Yes, please.
Okay, so I think we'll end up, and if anyone has anything want to say anything at the end, you can put it. Otherwise, okay, sir. So now it comes the day 2. We are ending up with this. So once again, we are thankful to Mithun sir. I think today we have learned the models, and then also that the